In this video, I'll be teaching you guys how to determine whether or not an ordered pair is an element of some Cartesian product. So hopefully by now you know how to solve Cartesian products. I have a video on Cartesian products if you want to watch that and you don't know how to solve Cartesian products. Then link will be down in the description just for you. But just for this example, just for this first example, I'm going to write down the Cartesian product of ax b and I'll show you how to do it. So whenever you're taking the Cartesian product of ax b, we're going to take the first element of A and then pair it with every single element of B. Okay? So let's write down A1, A2, and A3. Alright? And we take the next element of A, set A, which is B. Right? So we do B1, B2, B3. And we take the next element of set A and then pair it with everything in set B. So we write down C1, C2, and C, maybe, let's put it in the middle so it looks nice, C3. So this right here is AXB. Alright? So we want to figure out whether or not this ordered pair is an element of AXB. Well, we wrote down AXB already here. And there's A1, right? So this is an element. A1 is an element of AXB. But we want to figure out how we can do this even faster, right? I'm going to give you a shortcut. That's going to make this, it's going to make this super easy to determine whether or not some pair or some tuple is an element of some Cartesian product. So what we have here is, how do we build this? How do we build this set? Well, we started off with A in set A. Right? So we start off with set A, and we paired A with 1, 2, and 3. That means the first entry in every ordered pair must be an element of A. That means every single first entry, A, B, 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 C, 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 must be an element of this set A. Okay? So the order in which this pair is created is first, all of these, this first entry must be an element of A. This second entry in this ordered pair must be an element of B. Now, take a guess. Take a guess down here. What's the answer already, right? A, right? This letter A is an element of set A. This number 1 is an element of B. And this letter B is an element of set A. Right? So, hopefully you get what I'm saying by this, but let me reiterate it again as explicitly as possible, because I kind of just implied what I was talking about before. But right here, the order in which the entries inside the ordered pairs happen is the order of the sets that we have in the Cartesian product. So if we have A first, and we write down A as the first set, then we should expect an element of A first inside of the ordered pair. If we write down B second in this Cartesian product, then we should expect an element of B in the second portion. And an element of B here is just 1, right? So let's get this out the way. Let's go ahead and determine whether or not this right here is an element of BX, A. Well, if we take a look at this, we have B here. That means the first entry must be an element of B, because B is the first set written down in this Cartesian product. Is A, the letter A, an element of B? Well, B has 1, 2, and 3, so A is not an element of B. A is not part of B. Okay? So this right here, automatically we can already say this is not an element of BXA. Alright, how about this? Well, we have A here, the letter A here, and we have the set A here. Well, yeah, A, the letter A, is a part of the set A, right? So far we're doing pretty good. Okay, this is good. Let's put a check mark here, you know. We have a 1 here, and we have a B here. Well, 1 is the second entry. B is the second set we wrote down. That's pretty good, right? 1 is inside of B. 1 is right here inside of set B. So, number 1 is good. But, we have a third entry here. This doesn't make any sense, right? We don't have a third set. Where's the third set in this Cartesian product? Well, actually, there shouldn't be a third entry into this. There shouldn't be a third entry in this order. This is called an ordered triple, by the way. This is an ordered pair. This is an ordered triple, right? So since there shouldn't even exist a third entry, that means this guy this ordered triple isn't even an element of this Cartesian product. So this is false, right? Because we only have 2 sets here. We only took 2 Cartesian products, but we have 3 elements. That doesn't make sense. All right, what about this last one? Well, this last one, we have an A, and we already talked about this. We have the set A, so we should expect the first entry to be an element of set A, right? The letter A is an element of set A, so we're good on that, right? We have a 1 here, and we have a B here. 1 is in set B, and B, the letter B, is in set A. And since all of these entries are in the correct order, and they are the correct values, right? They are in the sets that they correspond to, then this is true, okay? All these entries are good. They are in the correct order, and they are the correct values. So A1B is an element of set A, Cartesian product, set B, Cartesian product, set A. So I've added a couple more problems for you guys. We have C35, and we also have BXA. Let's tell you this one real quick. We have 3 entries in here. We only have 2 Cartesian products. This is automatically false, right? We have 1, 2, 3, and this is just 1, 2. This is just false, okay? So that's just a quick shortcut that you can also take. If the number of entries in the ordered or the ordered triple, and the ordered triple doesn't match the number of sets in the Cartesian product, it's automatically false. All right, how about this? C35. All right, C35. Well, let's take a look at this. We have C. C is in A, right? C is in A. 3 is in B, but is 5 in B? Well, 5 is not in B. We only have 1, 2, 3 in B, right? We only have 1, 2, 3 in B. So, what is it? This is false. All right, how about this? Well, we have D here, and we have A. Well, we have A, B, C, and A, but we don't have D. So, since D is not an element of A, this is just not, this right here, this ordered pair is not an element of this Cartesian product. So this is false as well. All right, how about this? Oh, this is, look at this, man. This is just 1, 2, 3, 4, 5. We have 5 A's here. 5 A's? Well, we know A is a part of set A, so we should expect a bunch of A's on this side of the Cartesian product side. All right, let's take a look at this. Well, what does this notation mean? Well, we have A to the power of 5. Well, turns out Cartesian product looks an awful lot like the multiplication symbol, right? Well, apparently people thought good convention to shorten the way that we can write Cartesian product is just put a power. All right? And maybe if you guys have taken Calculus 3, you definitely have seen R3 or R2, right? Calculus 3 talks a lot about different dimensions. So that power you see in R3 and R2, that's actually a Cartesian product, just saying. That's just a fun fact. That's nothing to do with this video, right? But A5 stands for A cross A cross A cross A cross A cross A 5 times, right? We just have 5 A's multiplied together. So this is A to the power of 5. It's just A Cartesian product with itself 5 times. So we should expect 5 elements of A inside of the set. Sorry, not inside of the set. Inside of the tuple, okay? Inside of the tuple. And we do. We have 5 elements of A inside this tuple. Therefore, what is this? This is true. All right, what about this? Well, it's another way to format it, right? Remember, the power is just a shortened way to write something. Just a shortened way to write down multiple Cartesian products next to each other. So we have BXB, right? Because we have 2B, B to the power of 2. XA, XA, and XA, right? Because we have 3 A's. So what should we expect? We should expect 2 elements of B in the front and 3 elements of A on the last 3 values of this tuple. Well, we have a 3 here. 3 is in B. 2 is in B. B is in A. C is in A. And D. Well, D is not an A. Too bad. So sad. So, this right here is false. Right? We just have a single element that does not exist in the right spot. It automatically makes it so this is not an element. This right here is not an element of this Cartesian product.